With this limbic system, because of the areas where it is found, and because those areas are related to a lot of things that influence who we are and memories that we create, well, we're getting influences against, to our emotions. We get the visceral response to our emotions. For example, some people might actually throw up at certain things and that sort of thing. This is sort of the association for that. We have it influence our mood, sensations of pain and pleasure, the basic survival, food, water, reproduction. Also, the pheromones that will begin to get created once we hit puberty. It has an influence over these, and I'm sure everybody's familiar with the pheromones, okay? And in that cingulate gyri area is our satisfaction center. For example, satisfaction with the food that we're eating and that sort of thing. Those basal nuclei that we mentioned, where they're going to be found in that part of the cerebrum, into the diencephalon and the midbrain. The biggest thing with that is going to be motor function control, meaning our skeletal muscles. All right? So a lot of things are going to be influencing that. As I won't really ask you about that caudate and lentiform. Some of the other things that happen with the basal nuclei, they're good. They're very important. For example, planning, organizing, coordinating, movement, and posture. So think about all of that with skeletal muscle. And if you've ever, like last semester in part 1, how many of the muscles did you all have to learn? $30 maybe? 40? Did you have a lot more than that? Most of them were what we call superficial. Remember that? Okay? Most of them were superficial. But as we move into deeper muscles, all right? Deeper muscles are going to be the ones that are responsible for helping us maintain a lot of our posture, holding the head up, all this sort of thing. And they worked off of what was called a reverberating circuit. You don't have to know that. Because, this is something where it's going to pretty much be going 24/7 to keep those muscles functioning. We're getting feedback loops. What do you remember about feedback?
Stimuluses and responses to those stimuluses, either in positive or negative direction.
All right. You remember how we have the positive and negative feedback? Okay. So a feedback loop. All right. And what that's telling us, we're getting a feedback loop between basal nuclei, our thalamus, the cerebral cortex. We're going to find some of those loops are stimulatory, some of them are inhibitory. Meaning, when muscle movement occurs because we have groups of muscles working together. If one group is, do you guys remember them in part 1 talking about how you would have the agonist, the antagonist, the prime mover, all that sort of stuff for muscles? Okay. One group has to be antagonistic, work against the movement. One needs to make sure that the other group is stretching or is contracting. All right? So you're going to find that the feedback loops are making sure that those muscles create my coordinated movement. When we look at the right and left cerebral cortex, the right side controls muscular activity and it's receiving sensory information from the left side of the body. This is how we get that, well, the left is controlling right, right is controlling the left. Left is just vice versa. The information from both works or moves from either the left to the right because of those commissural fibers. Now, yes, for the most part, people do tend to be either left or right-brained. Left, definitely with math and speech. Right, three-dimensional, spatial, gives us recognition of faces, musical abilities, and some people do tend to be more right or left brained. Doesn't mean, well, now for some people, it's very dominant, okay? Like some people just definitely have, oh man, like she is so left brain, right brain, whatever the case might be. When we look at the brain, yes, it needs to integrate information we give it. The way that we know the brain functions and that it functions based on electricity, and that electricity is created by ions. You guys remember that? Movement, okay? Transmission of nerve signals is based on the inflow and the movement of ions, which creates electricity. The way we know this, EEGs. Ever had one? They stick all them little things on your head, they turn the machine on, and it should read out the stuff. Well, usually don't have one unless they think like brain damage or something is present. Well, what we do know from stuff that we have learned is they of course have said, or they labeled them as like these brain waves that we have, and they say that we have alpha, beta, theta, and delta waves. This is pretty much the case. If you look at what or at the point when the waves should show up, during rest, alpha should be the waves that are present. During mental activity should be beta. Theta, that's mostly for children. However, if there's a brain disorder or we're really frustrated, so a lot of us probably show up a lot of theta, but theta is usually what we see in the children. Delta is what we're going to find usually dominating in newborn infants, because what do? They sleep a whole lot, okay? Those should be occurring in our deep sleep. And then, if they show up at other times, like for example, if somebody was having an EEG and delta showed up while they were trying to get them to do some mental activity, that could be, that is indicative of some brain disorder. So if the waves show up at a time when they're not supposed to, that could be indicative of a brain disorder. And doctors would be able to look at the report from the EEG and say, oh, well, wait a minute, that brainwave should have been present at this time. So maybe there's this, hey, look, I will be the first to say neurology is not my strong point, okay? And that is pretty much how they would use the information from an EEG. So if we're looking at it, a lot of times, EEGs, when a person is having them, they tend to get them to do different activities. Of course, one of the areas that's been studied heavily is during our sleep. Why? We've got sleep cycles. Why is sleep important? To what? Well, it does help with brain function, but why? What happens if we're asleep? Yeah. Lots of things. Ever been sleep deprived? When? Most definitely. And they do that on purpose. Yes, they do that on purpose. Those who haven't served would get sleep deprived, times of like stress. Think about those 4 seconds. Do you tend to get sleep deprived when you might be trying to study for a test? And is that a good thing to do? No. 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 People always ask me, what is the best way to study? What is it? A little bit at a time. Should only do like 20, 25 minutes at a time, even though I have learned that our focus, our ability, our attention span, okay, it used to be attention spans were at like 20 minutes. I found out that now they're down like 7 to 10 minutes for an attention span. Holy cow. Alright? So, should study in small increments. What should you do in between the small increments of study? No. You should do something physical. You need to go out, take a walk, do a run, ride your bike, whatever. Come back, study, do it again. See a lot of you taking notes. See lots of different colors. What's the best color to help you remember? Red. Red, on that wavelength of color that we can see, red is the only color that we can see in 2 wavelengths. And because we can see it in 2 wavelengths, the brain accommodates it more. And you should always write Should never type it. Why?